All right, let's look at fields. All right, so when you look at real numbers with two operations, addition and multiplication, and the real number has a certain structure, right? So we know how the real numbers behave when you add real numbers or multiply real numbers together, right? So we want to kind of extract the essence of that structure, right? And so that's kind of what the field is, right? So here's the definition of a field. All right, so field F, along with two operations, addition and the multiplication. All right, F is a non-empty set, so it has to have something in there. And addition and multiplication has to follow the following conditions, right? First one is both addition and multiplications are associative. So that means that when you have A plus B plus C, you can add A plus B first, A and B first, then add C. Or you can do, add B and C first, then add that to A. All right, doesn't make any difference. So you can just add in any order. All right, multiplication is the same way. We can multiply A and B together and multiply by C, which is exactly the same thing as you multiply B and C together first, then multiply by A. All right, so addition and the multiplication must be associative. All right, and second condition is those two operations are commutative. That means that you can switch the order. So A plus B is exactly the same as B plus A, and A times B is exactly the same as B times A. Right? So the operations must be commutative. And this is kind of the property combining addition and multiplication. So it has to follow the distributive law. So if you do A times quantity A plus B, you can basically distribute this multiplication by A to each term to obtain A times B, AB, plus A times C. Right? Maybe I should put the multiplication sign in between. Right? So it has to be distributive, and a couple more. And so, to become a field, there must be an identity element, right? So 0 is the additive identity, which has this property. For any element, if you add the 0 to it, it's not going to change anything. It's going to give you A. So it doesn't change when you add. So 0 is the additive identity, and multiplicative identity is 1. If you multiply any element A by 1, you're going to get A back. Right? So there has to be additive identity and the multiplicative identity. Right? And the last condition is that it has to, every single element except for 0 has to have inverse, right? So additive inverse would be, so if you have A, additive inverse must be negative A. So when you add them together, you get additive identity, right? And for any element A, non-zero element A, but maybe I should be clear, A is non-zero, then you can always find its inverse. So the field has to contain inverse, so that when you multiply them together, you get the multiplicative identity 1. All right. So field is just a non-empty set with addition and the multiplication defined, and there are many different ways to define addition and the multiplication. But those two operations must follow these 5 sets of conditions. All right. So a simple example would be, of course, we kind of modeled after real numbers. So usual set of all real numbers along with the regular addition. We know how to add real numbers, and a regular multiplication is an example of a field, right? And if you don't want to take all real numbers, so we can actually do just the rational numbers. So take rational numbers, and we can still use the same regular addition because we know how to add the rational numbers, and we can multiply in a regular way rational numbers. Right? Those are a very simple example of field. Right? That's it. I hope that this was clear.